Hello everyone, welcome to my visual demonstration for the Object-Oriented Software Engineering Laboratory. Here we are going to see the third exercise, and third exercise is class diagrams for an e-commerce application system. So what exactly is a class diagram? Class diagram describes the attributes and operations of each class and the constraints that are imposed on the entire system as a whole. So this is also a part of the UML convention that is being used in any software engineering technique. The class diagrams are prepared and discussed within the confines of the company that is used to design that appropriate system, and it's not understandable by the client who is specifying a product or a system that is to be developed. So here in this class diagram, in this exercise, we're gonna explore different scenarios, and there are a lot of conventions used in class diagrams, and we are going to look at that also furthermore. And moving ahead, we now have the scenarios of the class diagrams. The first scenario is where a user can be in a customer or an admin can be inherited from a class user. I'll magnify this image for you a little more further. Okay, here we have the user attributes, that is username and password. So a user can be anyone, a customer or an e-commerce admin. A customer also has a username and password. An admin also has a username password. A customer, to make it more unique, has a customer ID, and an admin has his own seniority level, like more of like a senior admin, or the type of admin that takes care of the the background processes, more of like delivery and updating the products, or monitor the progress of the delivery, tracking the delivery. So like that is the kind of admin. These are the kind of users that are behind the scenes. So that's what we see in the first scenario. And here, to stress on what exactly is in this diagram, is the generalization. So the generalization is denoted by this triangle over here, and that means this customer and admin is inheriting the user class, the base class, and the multiplicity is many to many and many to many again. So what we see here is many users will be there, many customers will be there, and limited or many admins would be there. At least one or more admins will be there. So that's the intended purpose of specifying this, and this is called multiplicity. So that's what we have, a generalization and a multiplicity that is being discussed. So there's another example of a multiplicity with the same generalization concept. A customer a billing address and a shipping address can be inherited by the customer as well. So the billing address and shipping address can also be updated. So that has a multiplicity of a 1:1 and a 1:1 here as well. A customer can have only one billing address and one shipping address. Alright. Moving on further, we go to the second scenario. The second scenario states that a shopping cart contains cart items or products selected by a customer, and it's represented by aggregation. So here we have a cart, and cart can contain cart items, and the multiplicity here is one to many. One shopping cart can contain many cart items, and with these attributes, the respective attributes. So that's how it justifies the this class diagram as to why a multiplicity is one to many, and why what a class can contain the other class. So That is why a cart can contain cart items, and it's represented by this aggregation symbol. Next, moving on with the next scenario is the last scenario that you can see here is the composition. So here the composition is represented between one or more classes over here. Here I've taken for that instance 2 classes. So a product category can compose of a product, and that product can be checked if it's available or not. The multiplicity here is many to many. Many categories would be there, and many products would be there under that, and many products can have its own availability. That's why it's many to one. It can be available or not. That's what it's one, meaning that it's limited to an availability. So I could write here 0 or 1. For the time being, I've put it as 1 in case if it's available or not available. So that is the challenge in deciding the class diagram over here. So here the entire concept is based on composition of a class, and its multiplicity is represented here. So this is what we are doing when we are considering a product that is under a product category and checking if it's available or not. So that's what I've discussed right now, and yeah, that's it. So far these are the examples that you have seen so far in designing a class diagram. So that's all about this exercise, and thank you for watching this visual demonstration. Thank you once again. Goodbye.